All right, let's open up a cold case file from the early days of network security. Today, we're running a full forensic investigation on one of Wi-Fi's most infamous protocols, WEP.
Now, what we're covering today is actually just one piece of a much bigger picture. This whole explainer is drawn from a really detailed technical report by the RFI detectives, and it's part 4 of a massive 20-part deep dive into the standards that literally build our wireless world.
So here's the central mystery, right? WEP, or Wired Equivalent Privacy, was built with this incredibly important mission. But instead of becoming a bedrock of security, it became a lesson, a textbook case in total failure. So, what on earth went so wrong? To really understand the collapse, we first have to understand the intent. You have to look at what it was supposed to do before we can pick apart why it failed so spectacularly.
I mean, the name really says it all. Wired Equivalent Privacy. The whole goal was to take radio waves, this stuff that's just broadcast out into the open air, and make them just as private, just as secure as if you were plugging a physical Ethernet cable into the wall. It was all about giving us confidence that our data wasn't just being plucked out of the air by anyone nearby.
So how was Web supposed to deliver on that big promise? Okay, let's put this thing under the microscope and really inspect the tools it was using for the job.
At its core, WEP's security model was built on 3 fundamental pillars. These are the same things any security system needs, really. Keeping your stuff secret, making sure nobody's messed with it, and checking who's allowed in the door. Let's break down each one.
First up, confidentiality. To keep your data secret, WEP used something called the RC4 stream cipher. The idea was simple. Scramble the data going over the air so that anyone trying to listen in would just hear garbled, unreadable nonsense. In theory, a pretty solid plan.
Next up, integrity. WEP needed a way to guarantee that the data you received was the exact same data that was sent. For this, it chose a CRC32 checksum. You can think of this as a little mathematical fingerprint calculated from the data, which the receiver checks to see if anything changed along the way.
And finally, authentication. How did WEP control who gets on the network? Well, it used a simple password, what we call a shared secret key. Every single device, your laptop, your colleague's laptop, the access point, the whole shebang, used the exact same key to prove they belonged.
Confidentiality, integrity, and authentication. On paper, you tick all the boxes and it kind of looks like a complete system. But, and this is a huge but, the specific choices they made to implement these ideas were, frankly, disastrous. Now we get to the good part of our investigation, where it all came crashing down.
The first fatal flaw is buried deep in the encryption itself. To make that RC4 cipher secure, WEP needed something called an initialization vector, or IV. Its whole job is to make sure every single packet of data is encrypted in a unique way. Any cryptography textbook will tell you this value needs to be large and random. WEP's was, well, it was anything but.
Get this, the IV was only 24 bits long. That gives you about 16.7 million possibilities. Now, that might sound like a lot, but on any reasonably busy network, those IVs were guaranteed to start repeating, often within just a few hours. That repetition created predictable patterns, which is exactly what attackers needed to crack the encryption key. To put that in perspective, a modern standard like WPA3 uses a 48-bit value. That's over 280 trillion possibilities. So 24 bits wasn't just small, it was a catastrophic failure waiting to happen.
The second huge failure was that integrity check. Remember the CRC32? It's actually great for what it was designed for, detecting accidental errors like a bit of data getting corrupted by radio interference. But it was never, ever designed to stop a malicious attacker. Because it's a simple linear calculation, an attacker could literally flip bits in the encrypted message and then just calculate exactly how to flip the bits in the checksum to make it all look legit. The integrity check was effectively useless against a deliberate attack.
And the third flaw, this one's less about complex math and more about just bad operational design. That single shared key for everybody, it was static. It never changed unless an administrator physically went to every single device on the network and typed in a new one. Just think about that. One employee leaves the company, one laptop is compromised, and the key to the entire kingdom is out there, indefinitely.
And this quote from the source material just hits the nail on the head. It perfectly sums up the human side of this mess. In the real world, changing that web key was a massive headache for IT. And the result? It almost never happened. Keys that were supposed to be secret were used for months, sometimes even years, giving attackers a gigantic window of opportunity.
So yeah,
The protocol was completely, utterly broken. But why are we digging up this old case file today? Because the mistakes made with WEP, the reasons it failed, offer some powerful, timeless lessons for anyone working in IT right now. This table right here is pretty much the final verdict. We've set out with 3 goals: confidentiality, integrity, and authentication. And the evidence is crystal clear. On all 3 counts, it was a total failure. The encryption was broken, the integrity check was a liability, and the authentication, fundamentally insecure. Case closed.
So what do we as network pros take away from all this? First, you gotta audit your networks for old, legacy WEP-only devices. They might still be lurking, especially in IoT or operational tech. Hunt them down. Second, WEP's static key disaster is a huge reminder to prioritize strong, automated key management. Third, it proves that a security system is only as strong as its absolute weakest link. And finally, and this one is so important, just because something met compliance standards yesterday doesn't mean it's secure today. Security is always moving forward.
And that leads me to the final question I want to leave you with. Your network is probably built on WPA3 now, which is light years ahead of WEP. But think about it. Are you still making WEP-era mistakes in your security culture? Are you using shared passwords that never change? Are you putting off security updates because it's a hassle? The technology has definitely evolved, but those old bad habits, those WEP-era mistakes, they can still haunt a modern network if the culture isn't there to back up the tech.